Hello class and welcome back to more Sketch Science. Today we're talking about gravity, but not just gravity, gravity in space. Now I know what you might be thinking, but there's no gravity in space. Everybody floats around, right? You can do whatever you want. Wrong. Guess what? There's actually gravity in space. It just works a little bit differently. So first, we need to look at the work of a guy named Isaac Newton. Now, he came up with a few laws of motion. So, he came up with three. We're only looking at number 1 and number 3 today. So, the first law and the third law. The first one deals with something called inertia. Or, that's a fancy word of saying an object at rest will tend to stay at rest and an object in motion will tend to stay in motion. Unless acted on by an unbalanced force. So something moving is going to stay moving unless something stops it. Something not moving is not going to move unless something forces it to. That's the idea. So if you have a rock sitting in a field, not doing anything, rock in the middle of nowhere, not moving, nothing to move it, that rock will never move. It will sit there forever until someone comes and hits it with a car. Now when that car hits it, that's an unbalanced force. That's going to cause the rock to move. Now the car, on the other hand, if it has no brakes, there's no friction or anything, if that car's just going through a field at a certain speed, it's never going to stop. A flat field, no friction, no nothing. That car's going to keep going until it hits that rock, because that rock is an unbalanced force. That rock may stop it from moving. The rock might move when the car hits it, so it's the other way around. But that's the best analogy I have, is something not moving in the middle of a field will not move unless something forces it to. While something flying through a field, just moving, going through, is not going to stop moving unless something forces it to stop. That's the first law of motion from Newton. The third law is every action or every forced or unbalanced force has an equal and opposite reaction. So if you go back to that car and rock in the field, first inertia, one not moving, one moving. The not moving thing, it's not going to move unless something hits it. The moving thing, it's not going to stop unless something forces it to. That moving car ran into that not moving rock. The rock moved and the car stopped when it hit. Now, depending on the weight of the rock, the weight of the car, how fast the car was moving, will actually determine how far the rock moves and how quickly the car stops, because the car could only lose some of its speed. It still might be moving a little bit, but it'll slow down. And that's the third law, is depending on the weight of these two objects and how fast they're moving, that car puts so much force into the rock, but the rock is actually, even though it's not moving, is putting force back into the car. Now, what does this have to do with gravity and space? Well, imagine you're standing in an elevator. Imagine a person standing in an elevator. This elevator can go up or it can go down. Depending on it going up or down, and I don't know if you've been in an elevator before. If you have, you've probably felt this. Gravity feels different on them. Because when it's not moving at all, if this elevator is not moving, the force of gravity pulling you into the ground and the force of the floor pushing back on you are equal. Think about that. The floor is pushing on you, the earth is pushing up on you, while its gravity is pulling you down at the same time. That's what actually gives you your weight. Your mass or your mass gives you weight because of gravity. So the earth's mass pulls you down using its gravity. It pulls you down, but the floor pushes you up the same amount. That's why you don't fall through the floor. That's why you don't float up away from the floor, because if the floor was pushing up harder on you than gravity was pulling you down, you would float up. Now think about what I just said and about an elevator and how you feel when an elevator goes up or down. If you don't feel anything when you're standing still and the floor is not moving, it's because you're used to gravity and the floor pushing you the same amount, so you're not moving. But when that elevator starts going up, that means the floor is pushing up harder than gravity is pushing you down. Because if the floor is moving you upwards, you are being pushed up. That floor has to push harder on you. The elevator has to push harder on you than gravity is pulling you down in order for you to move up. That's how an elevator works. So that, remember the unbalanced force for the first law. First law is you won't move unless something forces you to. Well, that elevator is forcing you up into the air harder than gravity's pulling you back down. That's the only way it can get you to go up. Now, the other way, if the elevator is going down, if the elevator is heading back down, then gravity, the elevator floor, is pushing on you less, and gravity is pushing on you the same. So it's actually, gravity doesn't change. Gravity's going to stay the same no matter what on Earth. So the Earth has a certain amount of gravity. What the elevator does is it either pushes on you the same amount as gravity, that's staying still. It pushes on you more than gravity does, so it pushes harder up than gravity pulls down. That's how you go up. Or it doesn't push on you up very much and it lets you fall down because it gives gravity more strength than itself. It lets up on the gas so that gravity can pull you down. It's unbalanced. It's like a scale. So on one side of the scale, is the elevator. The other is the earth. Earth pulls you down, the elevator pushes you up. The floor of the elevator pushes you up. So in this case, if the elevator pushing you up is stronger, if it pushes harder, then you're going to start going up. If the elevator pushes less, then you'll go down. If they push the same, you won't move. That's how the first and the third law works. So if that unbalanced force pushes you up, though, the reason your body feels heavier, think about that. Your body feels heavier when an elevator is pushing you up. And that's because since it's pushing harder on your body has to push harder back on it. Your body feels that it's being pushed up, so then it has to push back down. It's the same with shooting a gun. If anyone's ever shot a gun before. With a gun, when something gets shot out the front, like a bullet gets shot out, of a gun, what happens? There's a kick, right? The gun shoots backwards. It comes back in your hand. That's because in order to shoot that piece of metal out that fast, there has to be some force coming back. Now, this metal's not as heavy. The bullet's a lot lighter than the gun itself. That's why the bullet flies a lot further. The gun doesn't. In space, it's the same way. So on Earth, there's friction, there's gravity holding things in place. In space, when there's less gravity, these things are magnified. Now going back, first, third law, space and gravity. Gravity is in space. People say, well, how come astronauts can float? Well, that's because they're always falling. Gravity causes things to fall, right? It falls back down to the planet. Well, what if I told you that falling doesn't mean you have to hit the ground? What NASA's figured out is they can put this space station up in the sky that people can ride in, live in, and it will constantly fall around the Earth instead of landing back down. It's the same reason why planets go around the sun and never run into it. Is because in space, this gravity, it's moving just fast enough sideways that it will dodge the Earth every time it falls around. It will never hit the ground. If you've ever noticed, astronauts train on planes for zero gravity by flying a plane in this shape. It's similar to an elevator. As you're going up, everything's heavier. They lay down on the ground because they'll feel heavier. The plane's got to go higher so it can do the drop, because if you're always going down, you'll eventually hit the ground. Then they do a falling motion. So when they're going up, they're laying down because otherwise it'll kind of feel heavier. Then, as they fall down, they're falling to the Earth fast enough in that airplane that they can physically, there's not enough gravity to catch them up with the ground. So they can fly in the air or feel like they're flying even though they're actually free falling. It's the same thing in space. They are falling so fast around the Earth and they're constantly falling that gravity doesn't have a chance to catch them up to the ground. They're always falling slower than gravity can pull them back down. That's the whole point of why people say there's no gravity in space. Because they're falling faster than the ground can catch them up. So if you're in an elevator and that elevator is moving so fast downwards, so this floor is putting so little force upwards on your body can't catch up to it. Because you're falling down not as fast as the elevator is. That's how space works. Gravity, the further away from an object you are, the less gravity you have also. That's another thing to keep in mind. So weightlessness in space. There is gravity in space. You/astronauts are just falling too fast to notice it. When you're in space, you're falling all the time, you just don't realize it. Like on space stations. Now, if you go far enough away from everything, because there's gravity, everything in space has gravity. If you think about it, our solar system, our sun, then you have like Mercury, Venus, Earth, Mars. If you think about it, if all these planets are orbiting the sun, there's got to be gravity out there, otherwise they're going to float away. So if Pluto, which would be like all the way out here or something like that, if it is still orbiting the sun, that means there's gravity out there pulling it around. Now, eventually, if you're far enough away from literally everything in space, yeah, there might not be any gravity. It might be an actual void. But for all we know, there's always gravity acting on something, even if it's so small you barely notice it. So instead of like zero gravity, consider it like always falling. Now, that is it for today's video. If you did have any questions about it, or if you'd like to add anything to it, please leave a comment down below. Be sure to like the video, so 1, you can find it quicker, or 2, I know you liked it, and 3, subscribe, so you can find the channel quicker and you don't miss any new videos when they come out. Thank you again for watching this, and I will see you next time.